Hello and welcome. I'm Mirko Peters, founder of the Data and Analytics LinkedIn page and host of the Data Science Show. If you're passionate about data or want to level up your analytics game, don't forget to hit subscribe on YouTube and follow our LinkedIn page. Trust me, you won't want to miss this. Today, we're diving into an exciting and impactful topic: mastering data, observability, and pipeline efficiency. This presentation will serve as your comprehensive guide to enhancing data management, rationalizing costs, and turbocharging performance optimization. We'll cover key concepts, practical strategies, and actionable insights to transform the way you manage your data pipelines. Whether you're a data engineer, analyst, or someone looking to better understand how modern data flows work, this session has got you covered. Let me start by asking you, have you ever faced challenges with identifying bottlenecks in your data pipeline or ensuring data reliability? If so, stick around because this is exactly what we're going to tackle. Ready? Let's dive in. Let's begin by unpacking data observability. Think of it as the health monitor for your data pipelines. First, let's define it. Data observability refers to your ability to monitor and understand the health and performance of data pipelines. This capability is crucial for data engineers to proactively identify and troubleshoot issues, ensuring data quality and reliability. Imagine it like a mechanic running diagnostics on your car before a breakdown happens. Second, what makes data observability powerful? The key components are observability metrics. These are the insights into data movement, reading, and transformation processes. They alert you when something goes off track, kind of like a warning light in your car dashboard. Data lineage. This tracks the flow and transformation of data across systems, helping you find the root cause of problems or assess the impact of a change. Finally, why should we care? The benefits are enormous. With enhanced troubleshooting, you save hours of manual checks and fix anomalies quickly, plus it drives cost efficiency, reducing maintenance costs, and making data processes more sustainable. So here's my question for you. Do you currently track observability metrics or data lineage in your pipelines? If not, what's holding you back? I'd love to hear your thoughts in the comments. Now that we understand what data observability is, let's explore why it matters so much in today's data-driven world. First, let's talk about proactive monitoring. Imagine having a system that alerts you to potential issues before they snowball into disasters. With continuous tracking, you reduce downtime and eliminate the need for those endless manual checks. It's like having a fire alarm that detects smoke before the fire gets out of hand. Second, we have enhanced data quality. Integrating automatic checks and alerts ensures that the data you use for decision-making is accurate and up-to-date. Think of it as the difference between relying on a crystal clear mirror versus a foggy one. It makes all the difference in visibility. Third, cost efficiency. Observability allows you to pinpoint inefficiencies and anomalies within your pipelines. This translates to informed decisions and cost-saving strategies. Every CFO's dream, right? Finally, improved compliance and risk management. By providing visibility into data lineage, observability ensures compliance with regulatory requirements and helps manage risks associated with data changes. It's like having a GPS for navigating the maze of compliance. Next up, let's talk about the backbone of any data system, the data pipeline. Think of it as the plumbing that moves water, or in this case, data, from one place to another, making it ready for use. First, let's define it. A data pipeline is a systematic flow where data moves through multiple processing steps, from its sources to a final destination. Each step acts as both an output and an input, creating a smooth and continuous flow. Second, we have the core components, data sources. Think of these as basins of water where data originates, such as databases, APIs, or sensors. Data processing steps. These are like water filters, purifying, enriching, and preparing the data for analysis. Data destination. This is your tap, the final output where stakeholders access the processed data, whether it's a dashboard, a report, or an application. Finally, there are different types of data pipelines. ETL, extract, transform, load, perfect for data warehousing. ELT, extract, load, transform, great for modern architectures like cloud platforms. Batch versus streaming. Batch handles big data in chunks, while streaming offers real-time insights, a game changer for dynamic environments like IoT and financial markets. Now, let's break down the essential building blocks of a data pipeline. Think of this as the anatomy of the system that ensures data flows smoothly and is ready for analysis. First, we start with data sources. These are the origins of your data, akin to a basin of water, where information is collected from various sources, like databases, sensors, or online platforms. This diversity of sources is what makes pipelines so versatile. Second, we have the data processing steps. These are the magic filters that transform raw data into something valuable. Let's dive deeper into these steps. Data extraction. This is like collecting raw materials. You gather data from various sources and store it centrally. Data transformation. Think of this as shaping raw clay. Algorithms convert data into usable formats, enriching and manipulating it to meet your needs. Data cleansing. This ensures quality by removing errors, inconsistencies, or irrelevant information, like cleaning up your workspace before starting a big project. These components work together to create a seamless and efficient data pipeline. Let's move to the first critical step in the data pipeline, data extraction and acquisition. Think of this as setting the stage for all downstream processes. Without strong foundations here, the entire pipeline could falter. Step 1. Identify data sources. This is where it all begins, determining where your data originates. Sources could include databases, APIs, flat files, or external providers. It's like identifying all the wells you'll draw water from. A thorough understanding of these sources is crucial for ensuring smooth extraction. Step 2. Gather data once you've identified your sources. The next step is extraction. This involves using specialized tools or scripts to connect, retrieve, and store the data in a central location, either temporarily or permanently. The key here is efficiency and reliability. If the extraction process is flawed, the entire pipeline risks contamination. Step 3. Store data centrally. After gathering the data, it needs a home. A centralized repository like a data lake or warehouse. This makes subsequent steps like transformation and analysis much easier. The choice of storage solution matters. It should align with the data's volume and scalability requirements. Now let's dig into the heart of the data pipeline, data transformation. This is where raw data is shaped, polished, and prepared for analysis. Think of it like cooking a meal. You start with raw ingredients and transform them into something delicious and useful. Step 1. Data extraction. This is the starting point, gathering data from various sources like databases, APIs, or flat files. It's like picking the freshest ingredients for your recipe and storing them in your kitchen, ready to be cooked. Step 2. Data cleansing. Before you start cooking, you clean your ingredients, right? Similarly, data cleansing involves identifying and removing inaccuracies, inconsistencies, or irrelevant data. It's also about handling missing values and formatting the data properly. Clean data is key to producing quality insights. Step 3. Data enrichment. This step is like adding spices or sauces to enhance your dish. By integrating additional information from external sources, data enrichment provides deeper insights and improves the quality of your analysis. Step 4. Data formatting and structuring. Finally, the data is shaped into a usable format, like plating your dish beautifully. Whether it's converting unstructured data into structured formats or applying algorithms for filtering, this step ensures the data is ready for reporting or analysis. Now, let's focus on one of the most critical stages in the pipeline, Data cleansing. Think of this as polishing your raw materials to ensure your analysis is built on reliable data. Step 1. Identification of inconsistencies. This is where we scan datasets to spot missing, inconsistent, or irrelevant data. It's like cleaning a room. You first identify clutter and mess. Detecting duplicate entries or formatting errors ensures that only valid data proceeds further. Step 2. Data formatting and standardization. Once inconsistencies are identified, the next step is to apply a consistent structure. For instance, dates might be converted to a standard format, and variations in naming conventions are corrected. Think of this as creating harmony in a song. Every note aligns perfectly, ensuring clarity and usability. Step 3. Validation and verification. Finally, we validate the cleansed data by comparing it against trusted sources or rules. This is the final quality check, ensuring data accuracy and reliability. Any lingering discrepancies are corrected, or irrelevant data is removed, leaving only what's trustworthy. Here's something to think about. How often do validation errors or inconsistencies delay your projects? Let me know how you handle these challenges. Your tips might help others. Now let's dive into the methods we use to extract insights from data. Analysis methods are where the magic happens, turning raw numbers into actionable intelligence. Statistical techniques. This is the bread and butter of analysis. Techniques like regression analysis, hypothesis testing, and descriptive statistics help uncover trends and patterns. These methods are the foundation of making data-driven decisions. 2. Machine learning algorithms. Here's where things get futuristic. Machine learning models such as supervised learning, e.g., classification and regression, and unsupervised learning, e.g., clustering, enable us to predict outcomes and automate insights. It's like putting your data on autopilot to deliver valuable predictions. Data visualization. Let's face it, numbers alone can be overwhelming. Tools like graphs, charts, and dashboards simplify complex datasets, making patterns easier to spot. Visualization is how we bridge the gap between raw data and decision makers, enhancing engagement and clarity. 4. Data quality checks. Finally, none of this matters without accuracy. Regular data quality checks help identify inconsistencies and anomalies, maintaining the integrity of your analysis. This step ensures you're building insights on a strong foundation. Let's bring it all together, because collecting and analyzing data is just half the battle. The real value lies in how we communicate the insights we uncover. This is where reporting and visualization come into play. Data reporting. The purpose of reporting is to summarize findings and present them clearly to stakeholders. Whether it's a dashboard, a structured report, or a presentation, the goal is to highlight key metrics and trends in a way that empowers decision-making. Think of it as the executive summary of your data story, short, sharp, and impactful. 2. Data visualization. Now, visualization takes things a step further. By using visual formats like graphs, charts, and infographics, we make complex data easier to digest. This approach is especially valuable for identifying patterns and outliers quickly. Effective visualizations act as a bridge, translating data into actionable insights at a glance. They not only speed up decision-making, but also deepen understanding. Now let's explore the different types of data pipelines. Each type has its unique role depending on how and when data needs to be processed. Batch data pipelines. These pipelines handle large volumes of data at scheduled intervals. They're systematic and efficient for offline processing. You'll often find batch pipelines used in ETL processes, data warehousing, and data lake management, perfect for cases where timely analysis and reporting of large datasets are essential. Think of them as the overnight delivery service of the data world. 2. Streaming data pipelines. In contrast, streaming pipelines process data in real time as it's generated or received. These are invaluable for environments where immediate insights are critical, like financial transactions, social media analytics, or IoT applications. Picture these as your instant messaging system for data. 3. ETL and ELT Pipelines. ETL, extract, transform, load. Here, data is transformed first before it's loaded into its destination. This is ideal for structured data processing and traditional data warehousing. ELT, extract, load, transform. In this method, data is first loaded into the destination, like a data lake, and transformed later. This is better suited for handling large data sets and leveraging the computational power of modern cloud-based systems. Now let's break down two core approaches to data pipelines: ETL, extract, transform, load, and ELT, extract, load, transform. These methods define how data flows and is processed within a system. ETL, extract, transform, load, to process overview. In this approach, data is extracted from multiple sources, moved to a temporary location, and transformed before being loaded into the final destination, typically a data warehouse. Transformation often includes filling empty fields or meeting specific requirements. Use case: ETL shines when you're dealing with disparate data sources that need consolidation and structure before analysis. It's perfect for traditional data warehousing scenarios where data integrity and structure are priorities. 2. ELT, extract, load, transform, process. Overview: ELT starts with data extraction, but instead of transforming the data first, it's directly loaded into a data lake or final server. Transformation happens after loading, leveraging the database's processing capabilities for flexibility and scalability. Use case: ELT is better suited for handling large datasets in modern architectures, especially in cloud environments. It provides quick access to raw data, enabling real-time analytics without the delays of preloading transformations. Let's now compare two fundamental approaches to data processing: batch pipelines and streaming pipelines. Each has its strengths depending on your data processing needs. Batch pipelines definition: these pipelines handle large volumes of data in chunks, processed at scheduled intervals. This approach allows for systematic and efficient offline processing. Use cases: batch pipelines are perfect for ETL processes, data warehousing, and data lake management. They shine in scenarios where immediate data processing isn't critical, but comprehensive analysis and reporting are. Think of batch pipelines as your scheduled maintenance team working behind the scenes to prepare your data. 2. Streaming pipelines definition: streaming pipelines process data in real time as it's generated. This enables continuous data flow and immediate insights, making them ideal for environments where time is of the essence. Use cases: streaming pipelines are indispensable for applications like financial transactions, social media analytics, IoT systems, and monitoring systems. They allow for real-time decision-making, ensuring actions are taken based on live data without delays. Picture them as your real-time responders, always ready to act on the spot. Now let's dive into hybrid data processing, a method that combines the best of both worlds: batch processing and real-time streaming. Definition and overview: hybrid processing is designed to handle both high-speed and high-volume data in dynamic environments. It integrates batch and real-time capabilities, making it perfect for businesses that need efficiency and immediacy simultaneously. 2. Key applications. This approach is widely used in industries requiring rapid data access and analysis, such as financial transactions and supply chain management. It's essential for decision-making processes that depend on timely insights, where the right information at the right time can make all the difference. Benefits of hybrid processing. Hybrid processing combines the efficiency of batch pipelines, handling large datasets, with the speed of real-time processing, delivering immediate insights. It enhances overall performance and makes pipelines more responsive to changing business needs. 4. Scalability and flexibility. One of its biggest advantages is scalability. As your data grows, hybrid pipelines adapt without compromising performance. They also offer flexibility, allowing you to integrate new data sources and meet evolving analytical requirements. Resilience and reliability. Finally, hybrid pipelines ensure continuous operation. Through redundancy and backup systems, they maintain data integrity even during component failures. They also support idempotence, guaranteeing consistent results regardless of re-execution. Let's shift our focus to an essential aspect of modern data pipelines: scalability. As organizations grow, so do their data needs. And scalability ensures your pipelines can handle the load without missing a beat. Definition of scalability. Scalability refers to a pipeline's ability to efficiently process large datasets and expand seamlessly as data volumes grow. This is critical for organizations dealing with ever-increasing amounts of data, ensuring there's no performance loss. 2. Key features of scalable data. Pipelines. Efficient data processing. Scalable pipelines handle high volumes of data using optimized techniques to maintain consistent performance, even under heavy workloads. Expandable architecture. Their design allows the addition of new components or resources, enabling organizations to adapt to changing requirements and integrate new data sources easily. 3. Importance in business applications. Scalable pipelines are a game changer in industries requiring high-speed transactions like financial services and supply chain management. They future-proof your infrastructure, ensuring your data systems remain robust and capable of meeting demand as your business grows. Let's talk about flexibility, an essential trait for any modern data pipeline. Flexibility ensures pipelines can adapt to evolving needs, technologies, and data formats without disruption. Adaptability to changing needs. Data pipelines must be designed to handle dynamic business requirements. Whether it's integrating new data sources or modifying data flows, flexibility ensures these changes occur seamlessly, avoiding significant downtime or excessive resource costs. 2. Integration of new technologies. Flexible pipelines allow businesses to incorporate emerging technologies and tools effortlessly. This ensures organizations can leverage advancements in data analytics and processing, maintaining a competitive edge. Dynamic data flow. Management flexibility enables real-time adjustments to data flows. Organizations can respond promptly to unexpected changes in data volume or type, ensuring continuous data availability and reliability for decision-making. 4. Support for diverse data formats. A robust pipeline should handle various data formats and structures. This is especially crucial for organizations that rely on heterogeneous data sources, enabling comprehensive analysis and reporting across multiple platforms. Resilience in data pipelines is a non-negotiable. It's all about ensuring functionality even when things go wrong. Let me start with a quick story, one that cost me quite a few sleepless nights. A few years ago, I was working with an education company that handled massive amounts of student data. Everything seemed smooth until one night our primary data pipeline failed, unexpectedly. Backup systems? We had none. Error handling mechanisms? Barely in place. What followed was a nightmare: disrupted operations, missed deadlines for critical student reports, and countless hours of troubleshooting. The lesson? Data resilience is not optional, it's essential. 1. Definition of resilience. Resilience refers to a pipeline's ability to maintain functionality despite component failures. This involves implementing redundant systems and backup processes to ensure continuous operation, so you don't face the chaos I once did. Key components for ensuring resilience: redundant infrastructure. Having duplicate systems ready to take over minimizes downtime. It's like having a spare tire in your car. You hope you won't need it, but it's there when you do. Robust error handling. Mechanisms that detect and respond to errors promptly are crucial. They ensure data integrity and keep operations running smoothly. 3. Benefits of a resilient data pipeline. Continuous data flow. Resilience ensures data is collected, processed, and delivered without interruptions. Minimize disruptions. Unexpected issues are contained, preserving operational efficiency and maintaining trust in your data outputs. Here's a takeaway. Do your pipelines have built-in redundancy and error handling mechanisms? If not, it's worth investing now to save those sleepless nights later. What measures have you implemented to ensure resilience? Let's share tips. Let's talk about a concept that might sound technical but is actually a lifesaver in data operations: idempotence. It ensures your data pipeline delivers consistent results no matter how many times an operation is repeated. Definition and importance: idempotence means that executing the same operation multiple times on the same input data always yields the same output. This is crucial for maintaining consistency and predictability in distributed systems, especially when failures or retries occur. 2. Benefits of idempotence error. Mitigation. Idempotence prevents issues like data duplication or inconsistencies when operations are repeated due to failures or retries. Simplified recovery. It makes recovery processes easier, as pipelines can safely rerun without the risk of unintended side effects, enhancing resilience and maintaining data integrity. As we wrap up, I'll leave you with this thought. Success is the sum of small efforts, repeated day in and day out. This aligns perfectly with idempotence in data pipelines. It's the repetitive but consistent efforts that keep your systems running smoothly and efficiently. In addition to my personal experience, there are notable real-world examples highlighting the critical importance of data pipeline resilience. Unity Technologies' $110 million ad targeting error in Q1 2022. Unity Technologies faced a significant data quality incident. Their audience pinpoint tool ingested bad data from a large customer, leading to major inaccuracies in their predictive machine learning algorithms. This resulted in a revenue loss of approximately $110 million and a 37% drop in share value. Equifax's inaccurate credit score. Fiasco Equifax, a major credit reporting agency, experienced a data quality issue where they provided incorrect credit scores for millions of consumers over a 3-week period. This led to consumers being denied credit or offered less favorable terms, causing significant reputational damage and potential legal repercussions for the company. These cases underscore the substantial financial and reputational risks associated with data pipeline failures. Implementing robust data observability and quality checks is essential to prevent such costly errors. Data pipelines are the backbone of analytics, but they can also become costly if not managed effectively. Let's break down the key aspects of rationalizing pipeline costs and tie it back to real-world scenarios. Understanding cost components can be divided into two main areas: infrastructure costs. These include expenses for hardware, software, and cloud services that support your pipelines. Data processing costs. These involve the operational expenses of transforming and processing data, often driven by machine learning algorithms and intensive computations. 2. Importance of cost governance. Effective cost governance is crucial, especially in cloud-based environments where costs can be unpredictable. Companies must implement robust strategies to monitor and control costs to sustain operations. Without governance, costs can spiral out of control, as seen in the case of Unity Technologies. Their $110 million error resulted from bad data, showcasing how unobserved inefficiencies in data handling can directly impact finances. 3. Strategies for cost rationalization. Implementing data observability tools helps identify inefficiencies and high-cost areas in your pipelines. Techniques like data compression, caching, and performance optimization can significantly reduce operational expenses. These strategies could have prevented incidents like Equifax's credit score inaccuracies, where faulty pipelines caused reputational damage and potential legal consequences. 4. Maximizing return on investment (ROI). Rationalizing costs ensures a better return on investment in data analytics. It involves continuous monitoring and adjustments to improve financial performance. For example, by investing in observability and cost control measures, organizations can allocate resources more effectively and avoid costly errors like those faced by Unity or Equifax. Let me start with this quote. "Beware of little expenses. A small leak will sink a great ship." Benjamin Franklin. When it comes to data pipelines, infrastructure costs are often those small leaks that can grow into massive inefficiencies if left unchecked. Let's break down why infrastructure costs matter and how to manage them effectively. Definition and importance. Infrastructure costs encompass the expenses related to hardware, software, and cloud services essential for building and maintaining pipelines. These costs form the backbone of data operations, influencing overall efficiency and performance. Without proper management, they can spiral out of control. 2. Components of infrastructure costs hardware expenses. This includes servers, storage systems, and networking equipment required for data processing and storage. Software licensing. Costs for tools and platforms that enable data management and processing. Cloud services. With cloud platforms operating on pay-as-you-go models, monitoring usage is crucial to avoid surprises in your bills. 3. Cost management strategies, regular audits, periodic reviews help identify underutilized resources, optimizing spending. Scalability, considerations. Investing in scalable solutions ensures infrastructure grows with your needs. Performance optimization, enhancing the efficiency of existing infrastructure, reduces the need for additional investments. Data is growing exponentially, and so are the costs of managing and storing it. Let's unpack the critical factors influencing data storage and management costs and how to handle them effectively. Understanding data storage costs. These include expenses for physical storage devices, cloud storage solutions, and software required to manage data. Storage is the foundation of every data pipeline, but it can also be one of the most significant cost drivers if not managed wisely. 2. Factors influencing storage cost volume of data. As data increases, so do storage needs and costs. Companies must plan for these growing volumes while maintaining efficiency. Data retention policies. Longer retention periods can drive up costs as organizations store more data than necessary. Striking the right balance is key. 3. Cost management strategies data. Archiving. Moving infrequently accessed data to lower cost storage options reduces costs. Data compression. Optimizing the size of stored data minimizes expenses without sacrificing accessibility. Impact of cloud storage solutions. While cloud platforms are convenient and scalable, they operate on a pay-as-you-go model. Monitoring and preventing over-provisioning is essential to avoid unexpected bills. 4. Balancing cost and performance. Investing in high-performance storage may come with higher upfront costs, but it can drastically improve data retrieval times and overall efficiency. This balance is critical for organizations aiming for long-term sustainability. Understanding data processing costs is essential to ensure your pipelines are both efficient and cost-effective. Let's break down the components and how to calculate them. Infrastructure costs. These are expenses related to hardware, software, and cloud services needed for building and maintaining data pipelines. Examples: servers, storage systems, networking equipment. To calculate: cost formula, infrastructure, cost acre server cost plus networking equipment. Cost plus software licensing fees, X usage time track resource utilization to align these costs with your actual requirements. 2. Data storage and management costs. This includes the costs of storing and managing data generated within the pipeline. Examples: cloud storage solutions and management tools. To calculate: cost formula. Storage. Cost has storage space used in GB X price per GB plus management Tool licensing fees. Regular audits can help identify underutilized storage to reduce expenses. Data processing costs. This includes expenses incurred for transforming and processing data, such as running SQL queries, machine learning models, and algorithms. Efficient processing ensures insights are timely and valuable. To calculate cost formula, processing cost, SAS, CPU hours, X price per CPU hour, plus RAM usage, X price per GB hour. Monitor the runtime and complexity of your queries and algorithms to optimize costs. 4. Tips for reducing costs, optimize workloads, avoid unnecessary data transformations, and reduce query complexity. Monitor usage. Use observability tools to track real-time usage and costs. Automation. Implement automation to schedule jobs during low-cost hours, especially in cloud environments. Let's shift our focus to a critical yet often overlooked aspect of data pipelines, security and compliance costs. Ensuring data safety is no longer optional, it's a necessity. Implementation of security measures. Security measures form the first line of defense in protecting sensitive data. Encryption and access controls. Organizations must invest in strong encryption protocols to safeguard data and access controls to restrict unauthorized usage. Continuous vulnerability checks. Regular assessments and audits are essential to identify and mitigate risks. These checks help ensure compliance with industry standards and regulations, protecting data integrity and confidentiality. 2. Compliance with regulatory requirements. Meeting regulatory demands can be costly, but is essential for maintaining trust and avoiding penalties. Data retention policies. Organizations need to ensure compliance with policies around data retention and deletion to meet legal obligations. Auditing and reporting. Allocating resources for ongoing audits and tracking data lineage ensures sensitive data is managed according to legal frameworks. This helps avoid fines and bolsters stakeholder confidence. Cost calculation. Example. To better manage these costs, organizations can break down security expenses into cost of security tools, CAR's licensing fees for encryption, plus vulnerability, scanning tools, compliance costs, time spent on audits, X hourly rate, plus costs for policy implementation. Investing in proactive measures not only minimizes financial risks, but also strengthens the organization's reputation. Here's a question. What are the biggest challenges your organization faces in balancing security investments with compliance costs? Let's explore some strategies. Let's now focus on an often underestimated component of data pipelines, maintenance and support costs. These costs ensure the long-term sustainability and efficiency of your systems. Ongoing maintenance expenses. Regular updates and technical support are essential for keeping your pipelines running smoothly. What's included? Costs for software updates, bug fixes, and system enhancements to maintain optimal performance. Neglecting maintenance can lead to system downtime or inefficiencies, which can become costly in the long run. 2. Data migration and integration. Costs as data sources evolve. Migrating and integrating new data into existing pipelines is unavoidable. This involves not just the technical aspects of data transfer, but also the need for additional resources to ensure compatibility and functionality. It's essential to budget for these changes to adapt to evolving business needs without disrupting operations. 3. Personnel and training. Costs. Managing and supporting data pipelines require skilled personnel. Costs include hiring, onboarding, and ongoing training for employees. As pipelines grow more complex, specialized roles like data engineers and analysts are vital to ensure effective management. Investing in training can boost efficiency and reduce the risk of errors, ultimately saving costs in the long term. Pro tip for cost management. Regularly review maintenance schedules and assess the ROI of training programs. Are there opportunities to automate updates or centralize training efforts to save time and money? Let's dive into an essential aspect of managing data pipelines: staffing costs. Behind every efficient pipeline is a skilled team, and investing in that team requires careful consideration. Overview of staffing. Expenses. Staffing costs cover hiring, training, and retaining personnel responsible for managing data pipelines. This includes data engineers, architects, analysts, and IT support staff. Roles critical for ensuring pipeline efficiency. Recruitment and onboarding. The recruitment process isn't just about finding the right talent, it's about integrating them effectively into your team. Associated costs include advertising roles, conducting interviews, and onboarding processes. Effective onboarding ensures that new hires contribute quickly and effectively. 3. Training and development. Continuous training keeps staff updated on the latest data technologies and methodologies. This includes costs for workshops, certifications, and ongoing education, key to optimizing pipelines and staying competitive. Retention strategies. Investing in retention strategies is often more cost-effective than hiring new staff. Offering competitive salaries, benefits, and career advancement opportunities helps maintain a stable, experienced workforce. So, impact on data. Pipeline efficiency. Staffing directly influences pipeline performance. A well-trained, adequately staffed team enhances the reliability of operations, leading to better governance and cost management. Neglecting this area can result in inefficiencies and higher long-term expenses. Pro tip: calculate staffing costs by considering total staffing costs, SARD, hiring costs, plus training expenses. Retention rate. Optimizing this equation can reveal where you might save or need further investment. Let's discuss a vital aspect of maintaining robust data pipelines: site reliability engineering, SRE, costs. Ensuring reliability isn't just a technical necessity, it's a financial investment. Monitoring and maintenance expenses. Continuous monitoring is critical to ensuring data accuracy and reliability. What it covers: tools and personnel dedicated to overseeing pipeline performance. Regular maintenance activities, such as updates and technical support, contribute to ongoing operational costs, keeping the data infrastructure efficient and robust. 2. Audit and assessment costs. Regular audits verify data integrity and compliance with regulatory standards. These require investments in time and resources. Costs vary. Complexity of data systems and frequency of assessments influence the overall SRE budget. Audits are a proactive measure to ensure systems are functioning as intended and meet compliance requirements. 3. Infrastructure and tooling investments. Specialized tools and infrastructure support SRE efforts. This includes software for monitoring, data accuracy checks, and performance optimization. Initial setup and ongoing costs can be significant, but they're essential for achieving high levels of observability and efficiency. Pro tip for managing SRE costs: automate where possible. Automated monitoring and auditing tools reduce manual intervention and long-term costs. Optimize audit schedules. Prioritize audits based on critical system components to focus resources effectively. Let's talk about data analytics and visualization costs, a cornerstone of turning raw data into actionable insights. Overview of costs. Analytics and visualization costs encompass all expenses tied to tools and services used for analysis and data visualization. These costs often include business intelligence software and data mining applications, the engines of insight extraction. 2. Types of tools. There's a diverse ecosystem of tools for analytics and visualization. Visualization platforms. Tools like Tableau, Power BI, and Looker simplify presenting data in digestible formats. Analytics software solutions such as SAS, R, and Python enable data mining, trend analysis, and statistical insights. The right mix of tools ensures clarity and precision in your data narrative. Implementation costs. Setting up analytics and visualization systems isn't free. It often involves licensing fees paid for using proprietary tools. Subscription costs. For cloud-based solutions or advanced features, data preparation expenses related to data cleaning and integration with existing datasets. Every step requires proper allocation to avoid budget overruns. 4. Importance of data observability. Here's where observability shines. Implementing observability tools helps track data flow, identify inefficiencies, and rationalize analytics costs. It enables better decision-making by ensuring that analytics efforts align with organizational goals and minimize unnecessary expenditures. A tip for cost optimization: regularly assess tool usage. Are there features or tools being underutilized? Consolidate overlapping functionalities and adopt open source solutions where possible. Now let's dive into implementation costs, one of the most critical factors when setting up data pipelines. Acquisition of external data. Imagine you're sourcing unique data from third-party providers. These might include subscription fees for ongoing access to datasets, licensing costs tied to specialized datasets or APIs, one-time purchase fees for raw data. These expenses can significantly impact your budget, making it essential to prioritize the data that truly adds value. 2. Integration with existing datasets. The next challenge is merging new data with your current systems. Think of it as trying to fit a new piece into a complex puzzle. This involves data mapping to align structures, transformation and cleansing to ensure quality and compatibility. While this process enhances the data ecosystem, it can also be resource-intensive and time-consuming. A lack of accuracy here might result in mismatches or poor decisions down the line. 3. Tools and technologies. Lastly, there's the investment in software and tools necessary for integration and management. This includes platforms like data processing tools for managing the workflow, analytics and visualization software for insights and reporting. These tools are essential for harnessing the true potential of your data, but they come at a cost that must be justified with ROI-focused strategies. Key thought: careful prioritization is critical. Ensure every expense aligns with your data strategy and provides measurable returns. Let's explore how data observability can be your cost-saving superpower. If you're serious about cutting costs while maintaining efficiency, this is where the magic happens. Identifying cost inefficiencies. Think of data observability as your detective in the world of pipelines. It helps you monitor pipeline performance and resource usage. Detect anomalies and degradation before they snowball into big expenses. Imagine spotting a minor leak in your data pipeline early. It's far less expensive to fix than repairing a burst pipe, right? 2. Optimizing resource allocation, compression, caching, and indexing. These are not just buzzwords, but tools to minimize storage and processing costs. Enhance data retrieval speed, saving both time and money. By reallocating resources more effectively, you ensure no dollar or byte is wasted. Enhancing decision-making. Leverage your observability metrics to pinpoint where to invest for maximum ROI. Inform strategic decisions to ensure long-term sustainability in your data practices. Ask yourself, are you investing where it matters most? 4. Streamlining. Maintenance and support automation is a game changer. Automate documentation and metadata management to reduce manual effort. Regularly review and resize hardware to stay lean without compromising performance. A practical takeaway: data observability doesn't just watch, it acts. It helps you turn chaos into clarity and inefficiency into opportunity. Let me ask you this: how often do we stop to measure the efficiency of our data pipelines? This slide takes us deeper into performance and efficiency insights, the heart of an optimized, data-driven operation. Identifying problematic pipelines. Think of data observability as a 24/7 surveillance system for your pipelines. It tracks performance degradation and resource anomalies. Early detection. It's like spotting a small crack in the dam before it floods the entire village. This approach minimizes downtime and maximizes performance. What's the most common issue you've faced in pipeline performance? Share below. Your solution might help others. 2. Cost rationalization. Strategies with observability. You pinpoint wasteful areas in your pipelines, like uncovering those extra charges in your monthly subscriptions. Make data-backed decisions to reduce costs while improving returns. Every dollar saved here is a dollar invested in innovation. Optimizing resource utilization. Leverage observability metrics to embrace data compression and optimize storage. Regularly review and resize your infrastructure to eliminate bottlenecks. It's all about squeezing the most value out of every bit and byte. The key is not just knowing where you can save, but acting on it effectively. Observability transforms insights into tangible results. Let me start by saying this. You can't manage what you can't measure. A classic quote by Peter Drucker, and it perfectly applies to what we're tackling today. Cost and resource inefficiencies in data pipelines. Identifying high costs and wasted resources. The first step in managing costs is knowing where the waste occurs. Are there redundant processes? Is storage being over-provisioned? This is where you ask yourself, am I paying for resources I don't need? It's not about cutting corners, but optimizing value. 2. Understanding cost components. Let's break it down. The big contributors are infrastructure, servers, networks, and storage, security and maintenance. Ensuring compliance isn't cheap. Staffing. Expertise comes at a price. Once you know what drives your costs, you're better equipped to manage them. What's your biggest cost driver? Drop it in the comments below. Data observability as a cost management tool. Think of observability as your financial advisor. It tracks every transaction or data movement, revealing inefficiencies. It's like switching from paper receipts to digital accounting, accurate and actionable. 5. Optimizing resource utilization. Lastly, techniques like data compression, caching, and resizing hardware streamline operations. This isn't just saving money, it's about making your entire pipeline leaner and faster. Imagine shaving minutes off your daily commute. Small tweaks, big impact. Let's start with this thought. Efficiency is doing better what is already being done. Data compression is the perfect example of how we can achieve efficiency in data pipelines without compromising functionality. Understanding data compression. So, what is data compression? It's the art and science of shrinking data while retaining its value, kind of like packing for a trip with only carry-on luggage. The goal, save space and speed up data transmission. It's all about using fewer bits to represent the same information. Imagine downloading a 10 gigabyte file in half the time because it's compressed. Convenient, right? 2. Types of data compression. Here's where the magic happens. There are two main types. Lossless compression. Think of a zipped file. When unzipped, you get every single byte back exactly as it was. Perfect for text and sensitive data. Lossy compression. Here, some data is discarded, like when you save an image for web use, ideal for media like images, audio, and videos where 100% fidelity isn't critical. Which one do you rely on most? Let me know below. Implementing compression in data pipelines. Here's the real kicker. Compression reduces storage costs and improves speed. It's particularly effective in high-volume data environments, cutting bandwidth usage and enhancing performance. Want a quick tip? Combine compression with caching for a powerhouse solution to manage heavy data flows. Let me kick this off with a quote. The quickest way to double your efficiency is to halve your delays. And that's where caching comes into play. It's the magic trick behind lightning-fast data retrieval. Overview of data caching. Data caching is like having your most used tools right at your fingertips instead of rummaging through a toolbox. What it does? Temporarily stores frequently accessed data in a high-speed layer. Why it matters? It slashes retrieval times and enhances performance, especially in data-heavy environments. For instance, imagine streaming a video. It's the cache that ensures smooth playback without those annoying buffering circles. 2. Types of caching strategies. Caching is not a one-size-fits-all approach. Here are two key strategies. In-memory caching uses RAM for rapid data storage and retrieval. Tools like Redis and Memcached excel here, supporting real-time applications, perfect for when speed is king. Disk caching stores data on disk drives for larger capacity at the expense of some speed. Think of SSDs for faster performance compared to traditional HDDs. Ideal for less frequently accessed data where storage efficiency takes priority. Which strategy do you lean towards for your systems? Let's compare notes below. Caching isn't just about speed, it's about smart resource allocation, balancing performance with storage needs. Let's begin with a thought. Efficiency is doing things right, but optimization is doing the right things. When it comes to hardware resources, we must shift our mindset from just keeping systems running to maximizing every byte of their potential. Assess current infrastructure. Start with a solid evaluation, just like a mechanic assessing a car before a long journey. Identify underutilized servers, storage systems, or networking components. Pinpoint performance gaps or areas where hardware fails to meet data demands. This step ensures that your infrastructure isn't just adequate, it's aligned with your organizational needs. 2. Implement scalable solutions. Scalability is the name of the game. It's not just about solving today's problems, but preparing for tomorrow's data deluge. Transition to cloud-based services or upgraded systems to handle high-speed and high-volume processing. The result? A system ready to grow with your business demands, without buckling under pressure. Can anyone share examples of scalable solutions they've implemented recently? Let's inspire each other. 3. Enhance resource monitoring. Think of this as putting a fitness tracker on your hardware. Implement monitoring tools that track resource usage in real time. Consider site reliability engineering, SRE, practices to minimize downtime and keep performance in check. With continuous tracking, you'll know where resources are being wasted and where they're being maximized. 4. Optimize data processing. Costs, finally, let's talk about trimming the fat. Analyze hardware usage and identify inefficiencies. Leverage this data to rationalize costs, keeping the system high-performing while reducing unnecessary expenses. Optimization isn't just a technical goal, it's a financial one. What are your best cost-cutting wins? I'd love to hear them. Let's pause for a moment and think about this. Have you ever tried to squeeze the last bit of toothpaste out of the tube? It's all about using every ounce of what you've got, right? Well, optimizing hardware resources is pretty much the same idea, but on a much bigger scale. Step 1. Assess current infrastructure. Here's where the magic starts. You need to take stock of what you have. I call this the hardware reality check. Are your servers underused, or is your network gasping for air during peak hours? This is about finding inefficiencies and plugging the leaks. Quick tip. A simple audit can often save more money than the shiniest new tool. Have you ever uncovered a hidden performance bottleneck in your system that saved the day? Share your experience in the comments below. Step 2. Implement scalable solutions. Now, once you've assessed your setup, it's time to think bigger. Scalability. This step is like upgrading your car's engine to handle both city traffic and long highway drives. Cloud-based services and flexible infrastructure are your best friends here. Transitioning to scalable solutions means you can grow without breaking a sweat or your budget. I remember working on a project where we scaled from handling 1 terabyte to 10 terabytes of data per week. The trick? We shifted to cloud first and never looked back. Enhance resource monitoring. Next, let's talk monitoring. Think of it like a fitness tracker for your hardware. It keeps tabs on performance and ensures you're not running your servers like they've just had 10 cups of coffee. Site reliability engineering, SRE tools, for instance, can be game changers here. Monitoring helps you act before problems spiral out of control. Step 4, optimize data processing costs. And finally, the grand finale, optimization. This is where you dig into the nitty-gritty of costs, analyze, tweak, and refine. From reducing storage expenses to minimizing latency, every tweak counts. Imagine a world where you not only meet your processing needs, but do so at a fraction of the cost. If there's one thing I've learned, it's that hardware optimization is like playing chess. Strategic moves make all the difference. Or, as someone wise once said, efficiency is doing better what is already being done. Let's tackle this one with energy, folks. Training and resource investment is the unsung hero of data success stories. Let me paint a picture for you. So, investing in data engineering skills, imagine. You're building a skyscraper. The tools are important, but without skilled architects and engineers, the whole thing collapses. In data pipelines, your engineers are the ones who lay the foundation, optimize the structure, and keep the entire system running efficiently. Training programs should be focused on the latest technologies like data observability, metadata management, and pipeline architecture. Why? Because a well-trained team is like a Formula One pit crew, fast, efficient, and always ready to solve problems on the go. 2. Resource allocation for data pipeline management. Now, let's talk about resource allocation. This is where the rubber meets the road. Investing in tools like cloud services and automation solutions isn't just an expense. It's an investment that pays dividends in efficiency and scalability. Understanding the total cost of ownership, TCO, is key. For example, implementing a monitoring system might seem pricey at first, but the long-term savings in maintenance and optimization make it worth every cent. 3. Continuous learning and adaptation. Here's the golden rule of data engineering. Evolve or get left behind. Technology is a moving target. Encourage a culture of continuous learning within your organization. Feedback loops can also make or break training programs. If you're not assessing the effectiveness of your investments, you're just throwing darts in the dark. What's your favorite method for staying updated on the latest trends in data engineering? Is it webinars, books, or maybe YouTube? Let us know in the comments. I like to think of training and resource investment as planting a tree. You may not see the results immediately, but with proper care and time, it grows into something robust, resilient, and incredibly valuable. Now this slide, Power of Data Lineage, is a topic close to my heart. And let me tell you, before I dive into the details, here's why I love this concept so much. A story. The big German car company. Years ago, I was working on a massive project for one of the biggest car companies in my city. It was the kind of project that keeps you up at night, not because of stress, but because of the sheer complexity. We were tasked with analyzing the data pipeline of their manufacturing process. Every piece of data, from raw materials to assembly line performance, had to be accounted for. The problem? There was no clear way to trace the data's journey. When something went wrong, like a delay in parts delivery or an issue in the assembly line, finding the root cause was like trying to untangle a massive ball of string, confusing and time-consuming. The turning point, data lineage. This is where data lineage came to the rescue. Once we implemented a robust data lineage system, we could track every step of the data lifecycle, from its origin to its transformation and final destination. Suddenly, everything clicked. We knew exactly where delays were happening, which systems needed attention, and how to optimize the entire process. Let's break down why data lineage is so powerful. 1. Understanding data source lineage. Data lineage gives you the ability to trace the origin, movement, and transformation of data throughout its life cycle. It's like having a GPS for your data, ensuring you always know where it's been and where it's headed. 2. Enhancing compliance and risk management in today's regulatory-heavy world. Documenting data changes is non-negotiable. Data lineage ensures compliance and reduces risks associated with unexpected data alterations. Streamlining data migration and upgrades. When you're planning a data migration or system upgrade, disruptions can be a nightmare. Data lineage smooths the way by helping you plan and execute transitions without unnecessary hiccups. 4. Improving system maintenance and performance. Finally, data lineage helps identify outdated or irrelevant data sources. It's like spring cleaning for your systems. Everything runs smoother, faster, and more efficiently afterward. To me, implementing data lineage is like adding headlights to a car. Without it, you're driving blind at night. And trust me, that's not where you want to be when working with mission-critical projects. All right, let's take the discussion a step further into the world of application lineage, a topic that perfectly complements data lineage. If data lineage is about tracking the journey of data through systems, application lineage is about understanding how the applications themselves interact within a pipeline. The backbone of seamless operations. Think of application lineage as the map of how different apps and tools in your system depend on and talk to each other. It's the bird's eye view of your digital ecosystem. 1. Definition and importance. Application lineage goes beyond the data itself and shows how applications influence and utilize the data pipeline. It provides insights into dependencies among applications. When one app falters, you immediately know which other systems will be affected. How data is transformed. Understanding how various applications utilize or alter data is crucial for pipeline optimization. 2. Benefits of application lineage. Let's highlight the wins here. Proactive monitoring. Spot issues before they spiral. With application lineage, you can predict disruptions based on dependencies. Compliance. Superpower. Regulatory requirements often demand detailed tracking of how data is processed across systems. Application lineage makes that a breeze. Faster. Troubleshooting. Ever experienced an issue where the data is fine, but the app workflow causes chaos? Application lineage narrows down the problem spot. 3. Integration with data observability. Here's where application lineage shines alongside data observability. Live documentation. Keeping track of changes across pipelines and applications is no longer a manual nightmare. This automates it all. Improved accuracy. By reducing human intervention, your systems become less error-prone. I remember working with a logistics company that had applications running in silos. No communication, no clarity. A failed warehouse tracking app once caused delays in their entire supply chain. By implementing application lineage, we connected the dots. Their systems started communicating, risks were predicted, and downtime decreased by over 30%. Application lineage is the glue that holds a complex data ecosystem together. Without it, you're navigating blind. But with it, it's like flying with radar. Clear paths and fewer obstacles. Let's delve into data source lineage, a critical component of modern data management that ensures your data remains transparent and traceable. This topic might seem a bit technical, but it's a game changer for organizations striving to optimize their data operations. Why data source lineage matters. At its core, data source lineage answers a simple but essential question. Where did the data come from, and how did it get here? It tracks the journey of data from its origin through transformations and into its final destination. 1. Definition and importance. Data source lineage maps out the flow of data across your systems. Transparency in data origin. It enables organizations to track and verify data, ensuring it's reliable. Improved accountability. Teams can better understand the source and history of data. How often have you faced challenges understanding the origin of a dataset? drop your experience below. 2. Compliance and risk management. Data lineage isn't just a good to have, it's a must-have for regulatory compliance. Audit trails provides a clear history of data changes for audits. Risk mitigation identifies points of vulnerability or potential risk in data handling. Facilitating data migration and upgrades. Migration and upgrades can be risky without a roadmap. Data lineage helps by identifying dependencies, ensuring systems won't break during migrations, planning transitions, minimizing disruptions. 4. Enhancing system maintenance, keeping old or redundant data sources can drag down system performance. Data lineage cleans up obsolete sources, improves storage efficiency, optimizes performance by removing irrelevant data. Levels of lineage tracking. Lineage tracking is often layered for deeper insights. Application lineage tracks dependencies among applications. Data source lineage focuses on the data's origin. Field lineage tracks individual data field changes for root cause analysis. Layered tracking adds depth to your data insights. It's like peeling back the layers of an onion, but without the tears. I once worked on a critical project for a large manufacturing company. They needed to understand how their ERP system data was affecting downstream reporting. With data source lineage, we traced inaccuracies back to a faulty sensor. That insight saved weeks of manual investigation and avoided financial misreporting. A real lifesaver. Data source lineage is your guide through the labyrinth of modern data ecosystems. It's not just about finding answers, it's about avoiding problems before they arise. Now, let's talk about field lineage, the hidden but powerful force behind robust data ecosystems. This concept gets down to the nitty-gritty, tracking data dependencies at the most granular level, individual fields, which is understanding field. Lineage field lineage is like the DNA of your data pipeline. It documents exactly how individual fields in your datasets interact and relate to one another. Precision in mapping. By tracking fields, you can pinpoint data issues down to the smallest detail, granular insights. This level of detail ensures you're never flying blind when troubleshooting. 2. Upstream and downstream dependencies. This is where field lineage shows its muscle. Upstream dependencies. Understand what fields contribute to your specific data points. This is key for root cause analysis. Downstream impacts. Know exactly which systems, reports, or dashboards will be affected when you tweak a single field. Managing dependencies avoids surprises during updates or migrations, because no one likes unintended disruptions. 3. Field usage and compliance. Field lineage also plays a pivotal role in ensuring data is used responsibly. Field usage. Identify whether a field is active or obsolete, helping to declutter your data warehouse. Sensitive data tracking. Stay on top of compliance by monitoring fields tied to sensitive data, ensuring alignment with regulations like GDPR. A large logistics company once faced discrepancies in their freight data. By leveraging field lineage, they discovered that a single, outdated field in their database was skewing their analytics. Fixing this not only improved accuracy, but saved them millions in operational costs. This example showcases how field lineage isn't just tech talk, it's a real business differentiator. Field lineage may seem like the unglamorous side of data management, but it's indispensable for ensuring accuracy, compliance, and agility. After all, as the saying goes, the devil is in the details, and field lineage gives you the power to tame them. All right, let's talk about something that makes every data professional's life a little easier: automating pipeline documentation. Now, I'll be honest, this topic is close to my heart because I've seen firsthand the chaos that happens when documentation isn't done right. Let me tell you a story. A real-life wake-up call. A few years ago, I worked with a financial company that had sprawling data pipelines. Every team was documenting manually, and it was, well, a mess. Imagine 20 people using different formats, updating things sporadically. One day, a critical data error crept into their dashboards, and no one could figure out where it came from. The problem? No consistent lineage, no proper catalog. It was like trying to find a needle in a haystack. After days of firefighting, they realized they needed to automate their pipeline documentation. And guess what? Within months, errors dropped by 70%, and everyone finally stopped pulling all-nighters. Why automation matters. This story isn't unique. When you automate your pipeline documentation, everything stays updated. Metadata, schemas, and data lineage are tracked automatically. No manual errors. You eliminate the guesswork and inconsistency that come with doing it all by hand. Think about it. How much time could you save if you didn't have to manually document every new data source or schema? Tools that make it easy. There are amazing tools out there like Collibra, Alation, or even open source ones like Apache Atlas. They capture metadata automatically, keep your data catalog clean and consistent, and they scale with you so you're not stuck revisiting old pipelines. Quality control built in. Now here's where it gets even better. Automation doesn't just keep things organized, it also keeps things accurate. With built-in data quality checks, issues get flagged early. Alerts tell your team exactly where something went wrong, so you're not wasting time troubleshooting. Manual processes are expensive, not just in terms of time, but also the mistakes that slip through. Automation cuts those costs by reducing labor and keeping everything consistent. And as your projects grow, your documentation scales right alongside them. You're future-proofing your entire data ecosystem. Better governance, less worry. Finally, automation makes your governance game strong. Sensitive data, locked down. Access control, done. Security, handled. It's like giving your pipelines a bulletproof vest. This isn't just about saving time. It's about working smarter, not harder. Trust me, once you start automating your pipeline documentation, you'll wonder how you ever lived without it. All right. Should we dive into the next topic? I promise it's just as exciting. Let's dive into one of the game changers in data management, metadata management tools. Why are they essential? Because they ensure that your data is not only organized, but also remains reliable, accessible, and secure. Automated metadata capture. Imagine having a system that automatically tracks and stores metadata for all your data sources, schemas, and lineages. That's what automated metadata capture does. No more manual intervention, no more missed updates. Your data catalog stays accurate and up to date effortlessly. Think of it as the autopilot for your metadata. 2. Consistency and standardization. One of the biggest challenges in data management is dealing with inconsistency across sources. Metadata management tools bring uniformity to your metadata, enhancing data quality and reliability. They make it easy to integrate new data sources and tools, creating a cohesive data environment. It's like everyone speaking the same language at a global conference, no misunderstandings, just seamless collaboration. 3. Integration with data governance. Let's not forget governance. These tools play a crucial role in managing access to sensitive metadata and ensuring compliance with regulations. By enhancing the security and integrity of your data catalog, you ensure that only authorized users can access critical information. It's like having a high-tech security system for your most valuable asset, your data. Investing in metadata management tools isn't just about saving time. It's about building a solid foundation for data reliability, consistency, and security. What's your experience with metadata management? Do you have a tool you swear by? Share it in the comments. Let me share a real-world story that highlights the transformative power of automatic data quality checks. A leading e-commerce company was struggling with inconsistencies in its sales data. Orders were often being processed with incorrect pricing, and inventory reports showed discrepancies. These issues not only frustrated customers but also created massive inefficiencies within their operations. the root cause, data quality issues that went unnoticed until it was too late. Enter automatic data quality checks. By integrating these checks directly into their data pipelines, the company was able to proactively monitor and validate incoming data in real time. Errors in pricing or inventory mismatches triggered instant alerts and notifications, allowing the data team to address the problems before they affected customers. The results were incredible. Customer complaints about pricing errors dropped by 80% within the first 3 months. The operations team saved hundreds of hours by not having to manually trace errors in the pipeline. Revenue leakages caused by untracked inventory mismatches were eliminated entirely. What's fascinating is how these alerts became the company's early warning system, acting like a smoke detector for potential data fires. It not only improved their data governance, but also boosted team confidence in decision-making processes. So if you're managing large data pipelines, ask yourself, are you catching data inconsistencies before they create chaos, or are you firefighting problems after they escalate? Let's talk in the comments about your experiences with real-time data monitoring and what tools have worked best for you. All right, let's talk about something absolutely foundational for managing data effectively: data governance tools. Imagine you're the captain of a ship navigating through a stormy sea of data. You need a solid crew, precise navigation tools, and clear guidelines to avoid crashing into the rocks. That's what data governance tools do. They provide the structure, control, and oversight needed to steer your data pipeline ship towards success. Without these tools, things can get chaotic fast. Think of the countless data breaches we've all read about. More often than not, they result from poor governance. These tools are the unsung heroes ensuring your sensitive data is protected, your processes are streamlined, and your organization stays on the right side of compliance. Now let's break down what these tools cover. 1. Access management. This is your gatekeeper, your bouncer at the club of data. Tools like Okta and AWS Identity and Access Management, IAM, enforce strict role-based access controls. They ensure that only the right people access sensitive information. Imagine working with customer financial data or healthcare records. There's no room for error. Access management tools help you sleep at night, knowing unauthorized hands won't mess with critical data. 3. Compliance and auditing. This is your watchdog, keeping everything in check. Tools like Informatica Axon or Apache Atlas ensure your data pipeline is always in compliance with governance policies and industry regulations. These tools provide detailed audit trails, so if someone asks who accessed this data and why, you'll have the answers ready. They're particularly critical for industries like finance and healthcare, where compliance is non-negotiable. Data governance is not just about ticking compliance boxes, it's about enabling your organization to trust its data. When these tools are working seamlessly, your teams can focus on analytics, innovation, and delivering value without worrying about the security and reliability of the data. What's exciting is how these tools are becoming smarter with automation and AI. Some of them even use machine learning to suggest improvements in your governance strategy. Imagine a tool that not only manages your data, but also helps optimize your processes. 2. Metadata management. If access management is the bouncer, metadata management is the librarian. Tools like Elation and Collabra organize your data assets, keeping everything cataloged, up to date, and easy to find. These tools automate the tedious process of tracking where your data lives, what it's connected to, and how it's being used. Picture a massive library without a catalog. Chaos, right? Metadata management ensures that data is accessible and trustworthy. Now here's a thought. Should we explore making videos or tutorials about some of these tools? Whether it's a deep dive into AWS IAM, a practical walkthrough of Collabra, or real-world applications of Informatica Axon, these could be incredibly helpful for anyone looking to strengthen their data governance game. What do you think? Let me know your thoughts below. Reducing the total cost of ownership, TCO, isn't just about cutting expenses. It's about optimizing your processes, increasing efficiency, and leveraging tools that deliver better results in the long term. Here's your step-by-step guide to achieving this. Automate your documentation, what to do, use tools like Apache Atlas, Colibra, or Informatica to automate the tracking of metadata, including data sources, schemas, and lineages. Replace manual processes with automated systems to ensure your data catalog stays accurate and up to date. Why it helps: reduces human errors, saves time spent on manually updating records, ensures consistency across all documentation efforts. Schedule periodic automated scans to detect and document changes in real time so your catalog never falls out of sync. 2. Integrate automated data quality checks. What to do: implement automatic data quality solutions like Great Expectations, Talent, or Trifacta to identify inconsistencies. Configure these systems to send alerts and notifications when anomalies or outdated information are detected. Why it helps: prevents the use of flawed data in decision-making, identifies issues early, reducing the impact of costly errors, ensures that your data pipeline delivers clean and reliable outputs. Set up dashboards to monitor data quality trends over time for better long-term improvements. 3. Utilize metadata management tools. What to do: deploy metadata tools such as Alation, Colibra, or Dataido to organize, track, and store metadata efficiently. Ensure these tools are integrated with your broader data pipeline for seamless metadata management. Why it helps: enhances the reliability of your data catalog by reducing operational costs associated with manual updates, makes your data searchable, understandable, and trustworthy. Regularly train your team on the features of metadata tools to maximize their value and usage. 4. Implement robust data governance practices. What to do: establish clear frameworks and policies for role-based access controls using tools like Okta or AWS IAM. Monitor compliance continuously and conduct audits to ensure alignment with regulations. Why it helps: protects against data breaches and compliance penalties. Ensures only authorized users have access to sensitive data. Align your governance framework with industry standards like GDPR, HIPAA, or SOC 2 for maximum compliance coverage. Integrating all of these elements into your strategy creates a feedback loop. Automated documentation supports metadata management, which improves data quality, which strengthens governance, and the cycle continues to lower your TCO while improving efficiency. Let's face it, business changes are as inevitable as Monday mornings. Whether it's a new product launch, a shift in market demand, or an organizational restructuring, these changes ripple through your data ecosystem like a stone tossed into a pond. But what if you could map those ripples, predict their path, and minimize their impact? Enter the power of data lineage. 1. Understanding data. Lineage business changes can affect every nook and cranny of your data pipeline. With data lineage, you get a clear bird's eye view of where your data originates, how it moves, and where it ends up. Why it's crucial: helps visualize how modifications in business processes impact data flow, ensures stakeholders stay informed about potential implications. Imagine this: a team modifies a pricing model in your ERP system. Without Lineage, identifying which dashboards or reports are affected is like finding a needle in a haystack. With Lineage, it's as simple as following the breadcrumb trail. 2. Identifying affected components. When a change happens, say a new data field is added, it's vital to pinpoint which tables, dashboards, or reports it influences. How it works: use Lineage tools like Apache Atlas or Colibra to identify dependencies. Immediately highlight affected areas, enabling faster adjustments. Example: picture a marketing campaign suddenly requiring a new data field for customer segmentation. Using data lineage, your team quickly sees which analytics workflows need updates, saving hours of manual checks. 3. Mitigating risks associated with changes. Here's where the magic happens. Robust Lineage practices not only trace impacts, but also proactively manage risks. Key benefits: reduces the chances of errors caused by unnoticed dependencies, maintains data integrity and reliability. Think of it like this: changes can be disruptive, like rearranging furniture in a busy office. Lineage acts as the floor plan, helping you rearrange thoughtfully without tripping over chairs. Engaging introduction. Let's tie everything together. We've walked through the building blocks of data observability, explored lineage, metrics, and proactive monitoring. But what's the big picture? How do all these elements work together to transform your data operations? This slide is the perfect wrap-up for anyone striving to master pipeline efficiency and data integrity. 1. Proactive monitoring. Data observability is your team's superpower to stay ahead of issues. Instead of reacting to problems, engineers can monitor systems in real time, troubleshoot more efficiently, and minimize manual checks. Key takeaway: a proactive approach reduces downtime and keeps your operations running like a well-oiled machine. Example: imagine catching a storage anomaly before it spirals into delayed analytics. Now that's observability in action. 2. Key metrics for analysis. Metrics are the pulse of your data ecosystem. They provide actionable insights into movement, transformations, and system health. Why? It's crucial. Enables early detection of issues like slow queries or bottlenecks, informs strategic improvements in resource allocation. Think of metrics like a fitness tracker for your data. It's all about knowing where to improve. 3. Impact evaluation. Ever wonder which issues are worth addressing first? That's where impact evaluation shines. By understanding the ripple effect of a data anomaly, teams can prioritize effectively. Key benefit: saves resources by focusing on critical areas instead of chasing minor bugs. Real-life scenario: evaluating the impact of a dashboard outage ensures business-critical analytics are restored first, because not all pipelines are created equal. 4. Data lineage insights. This one is the cherry on top. Data lineage doesn't just show where data comes from, it provides the blueprint for fixing problems at their root. Core advantages: streamlines issue resolution by showing exactly where data breaks down. Ensures long-term quality by identifying faulty applications or outdated transformations. It's like having X-ray vision for your data flows. See through the noise and fix what matters most. Let's take a moment to summarize the essence of data pipelines, a cornerstone of modern data ecosystems. Imagine a highway system designed to connect various cities, your data sources, transport goods, data processing, and deliver them to their final destinations, data endpoints. This slide beautifully ties together everything about how data pipelines drive seamless and reliable data flow. 1. Definition and flow. A data pipeline is the structured, orchestrated flow of data from multiple sources to its final destination, ensuring a consistent and reliable transfer process. Think of it as the assembly line in a factory. Each step adds value until the final product is ready for delivery. Why it matters? Without a well-designed data pipeline, the whole data ecosystem risks bottlenecks and inaccuracies. Key components. Every effective data pipeline comprises data sources, where the journey begins. Processing steps, the transformative stages, e.g., cleaning, aggregating. Destinations, where the processed data lands, ready for use. Example: from raw IoT sensor data to aggregated insights visualized in dashboards. 3. Types of processing. Data pipelines can be categorized into two main types. Batch processing handles large data sets at predefined intervals, perfect for financial reports or ETL jobs. Streaming processing processes data in real time, ideal for live dashboards or fraud detection. 4. Cost management. Running data pipelines isn't just about efficiency, it's also about managing costs. This includes infrastructure and storage, processing and maintenance, governance and security. Pro tip: monitor usage patterns to avoid over-provisioning and optimize cost-to-performance ratios. 5. Importance of data observability. We've emphasized this repeatedly because it's the linchpin of pipeline efficiency. Detect issues early, identify anomalies in data flow, optimize resource allocation, prevent overloading and inefficiencies, ensure data quality, consistent insights, faster decisions. Data pipelines are more than just technical constructs. They're the lifeline of modern data strategies. So let me ask you this. Are your pipelines optimized for cost, performance, and observability? And would you be interested in videos diving deeper into building and monitoring pipelines? Drop your thoughts in the comments or reach out. Let's dive into a topic that's close to every organization's heart, managing costs effectively. Rationalizing cost isn't just about cutting corners, it's about making smart, sustainable choices that balance performance with financial efficiency. If you've ever wondered how to keep your data pipelines lean but powerful, this is where it all comes together. 1. Understanding cost components. The costs of data pipelines extend across several areas: infrastructure, cloud or on-prem resources like servers. Data storage, from databases to archival systems. Processing, the computational power needed for data transformation, security, maintenance, staffing, and SRE. All the unseen heroes that ensure your pipelines don't break down. Without clear visibility into these components, costs can spiral out of control. 2. Importance of cost governance. This is where things get strategic. Governing costs means having a clear framework to predict and control expenses, especially in dynamic environments like the cloud. It's about setting limits and monitoring thresholds, optimizing resource usage to align with business needs. Lack of governance often results in surprises during billing cycles. Fun fact, did you know that cloud sprawl is one of the top culprits for untracked costs? 3. Role of data observability. Here's the secret sauce: data observability. It tracks performance bottlenecks, identifies inefficiencies in real time, helps to align resource usage with demand. Think of observability as your budget radar, spotting inefficiencies before they blow up your expenses. 4. Strategies for cost reduction. Finally, let's talk tactics. Data compression. Reduce storage and bandwidth requirements. Caching. Cut down retrieval times and costs. Hardware optimization. Scale smartly with your workload. Investing in training. A knowledgeable team makes better financial decisions. Every little tweak adds up to massive savings over time. 4. Strategies for cost reduction. Finally, let's talk tactics. Data compression, reduce storage and bandwidth requirements. Caching, cut down retrieval times and costs. Hardware optimization, scale smartly with your workload. Investing in training. A knowledgeable team makes better financial decisions. Every little tweak adds up to massive savings over time. Welcome to the final slide of our deep dive into data observability and pipeline efficiency. Think of this slide as the grand finale, a place where we bring together all the threads we've explored and map out what's next. If this series has been like building a car, this is the test drive moment where we see how all the parts come together and look at the road ahead. Emphasizing automation in data management, imagine having a system that automatically updates itself, never forgets to record a change, and saves you hours of manual labor. That's what automation brings to data management. By integrating automation into documentation and metadata handling, you ensure smoother operations and fewer costly errors. It's like putting your data management on autopilot. Importance of data lineage. Data lineage provides the clarity needed to understand how data flows and transforms across the system. It's not just about knowing where your data comes from, but also how it evolves and how reliable it is. With effective lineage, you get full transparency, which is critical for compliance, risk management, and making informed decisions. Think of it as having a map when navigating a complex city. Focus on cost rationalization. Managing costs isn't just about cutting expenses, it's about optimizing value. Cost rationalization ensures that your investments in infrastructure, tools, and teams deliver maximum ROI. By applying strategies like observability and governance, you can achieve operational efficiency without overspending. It's like trimming the sails to catch the wind, ensuring you don't waste energy. As we close this series, let me leave you with a key takeaway. Data is only as valuable as the systems you build around it. By focusing on automation, lineage, and cost rationalization, you're not just managing data, you're turning it into a competitive advantage. Thank you for sticking with me, Mirko Peters, through this journey. If you love this series, don't forget to subscribe to my YouTube channel and follow Data and Analytics on LinkedIn for more deep dives like this. And here's a question for you. What's the next big data topic you'd like us to tackle? Let me know in the comments. If you're a sponsor or a thought leader, I'd love to have you join me in future live streams on the datascience.show. Let's keep the conversation flowing.